Alrighty, my name is Justin Ross. I am with Fluke Biomedical. I'm one of our senior technical sales engineers. I have a bit of a weird job. So anybody who lives in this Northeast, I'm also a sales rep. So my team covers from Washington, DC to the tip of Maine. And then I double over and I work with our marketing team. So you see a lot of our training videos and how-to videos. I get to help out with those. I can tell you in this advertising picture, this is not me because there's an entire fingertip on that. So that doesn't match. Okay. Anyways, so we have a very long PowerPoint presentation for you. So we're going to go ahead and we're going to get into this PowerPoint presentation. You're driving. Oh, wait, am I driving? All right, so the first question I have for you, it's actually just two questions is what I have. The first one is what do you want to see in today's presentation? And you don't have to raise your hand. If you want to raise your hand and say, hey, listen, there's something really specific I'd like to see, please let me know. If not, as I'm coming towards the end, I'm going to go through this demonstration. We're going to walk through the product. We're going to walk through some of the advantages. We're going to show you some really neat tips and tricks. When we get towards the end, and I want to have a nice, long, prolonged question and answer time. So if you think about what you wanted to see today, if I don't address those concerns, please bring it up, please. And if for some reason we run out of time, swing by the Fluke booth 101, and we will make sure that we will answer any of your questions. That was my first slide. Yes, sir.
So yeah, in terms of what we'd like to see, just curious if this is one of the units that can feed data directly.
It is. It can. That's a great leading question. He's talking about, can our analyzer run your procedure for you, capture your data, and enter it right back into your work order? And the answer is yes, and we're going to show you how that does that. That's a great question. So my next question, my second PowerPoint, and then you can go ahead and shut this off as far as I'm concerned, dear. This is it. Oh, you got it. All right. Can I ask you by show of hands, who's running BD-Alaris pumps? Ooh, that takes, John, did you count all these for me? No, you don't have to. So about 2/3. Any Baxters? Oh, it's gonna be one of those groups. I love it. How about B Bronze? Okay, a few. Abbott's. Any of the Abbott? The Plum Duos? They're ICU Medical now, I guess. I should say ICU Medical Plum Duos. Nobody? Okay. Does anybody have anything that's not on that list? That's nice and easy. So our biggest customers, we're going to be talking about Alaris people. That's great. Okay, so now if you could just go ahead and throw us to the camera. All righty. Thank you. You did awesome. So we're here to talk about our IDA-6 Infusion Device Analyzer, version 6. And this is a really cool analyzer. And I like to start off with this little demonstration here. And the reason I like to do this is a huge syringe. Everybody can see this is a massive volume of a syringe. And the reason I like to pull out the syringe very first is if I draw the entire fluid level of this, does anybody remember the 30s when I didn't have to squint to see these things? Lord. There we go. Here's the entire volume of the syringe. Ready, Lynn? It could be water or vodka. I'm not telling you which till you catch it. Okay. So here's the entire volume of the syringe. It's massive. 1, 2 droplets. 2 droplets of water. So the entire volume of the syringe is 50 microliters, 0.05 milliliters. It's a very fine amount of fluid. And there's a reason we want to discuss this amount of fluid. So I'm going to take this syringe and I'm going to fill it halfway up. And then I'm going to squint really hard to, it took my light away. And I'm going to try to figure out where that 25 milliliter line is. Good gravy. Yes, I do. We're going to have to say this is 25 microliters nominal. So if I take this 25 microliters, and if I can measure the volume of a single droplet of water, would anybody be impressed? Because if anybody grabs a graduated cylinder, does anybody have a graduated cylinder in their shop? All my layers people, are you using scales or are you using graduated cylinders? Scales? In your scales, are you using 5-point scales or single-point scales? Oh, that's a great question. Does anybody know that? This is something to consider when you're buying a medical grade scale, right? Does it have 5 pressure transducers in it or 1? How many decibels can your scale read out to? Does anybody know? You can read 3 decimals? Does it have a bubble that tells you if it's level? No, there's an issue with that, isn't it? Because if that scale's not level and you have the pressure plate on it, is that pressure plate flying directly down or is it slightly keltered, which would cause drag? So that's a good question. Who has the highly calibrated medical grade towel underneath their scale because they slop water all over the bench? I'll admit it, my shop did, because we always had a mess. So when you put all those factors together, are you actually able to measure that single droplet of water? It's a good question, isn't it? So let's talk about the single droplet of water here. I'm going to go to another camera view, and I'm going to go into my that was pretty cool, wasn't it? All righty. I'm going to go to channel 1. The IDA-6 comes in 4 options. You can get a single channel, 2 channel, 3, or 4. And if you buy a 1 or 2 channel and you decide, hey, this is really awesome, like the guy told me at MD Expo, and I'd like to get another channel, we can upgrade this for you. You simply buy another channel and you slap it right in. But we'll talk more about that here in a minute. 25 microliters. Can I get a drum roll? Is that cool? All right, here we go. 25 microliters has been connected to the front of the IDA-6. Oh wait, wrong button. John's gonna make fun of me because I told him I could drive this thing upside down. Measure, flow and volume. I'm gonna push play. And what you wanna see is right here where it says volume. And can you see on my fingers, as soon as I start to push this button, you notice we had an instantaneous pickup. In case anybody didn't catch that, we're accurate to 1/25th of a single droplet of water. 1 microliter. Not only are we accurate to 1 microliter, but we have 1% resolution of 1 microliter from 0 to 3,000 milliliters an hour. Kind of impressive, right? The reason I want to talk about this, hey, that wasn't bad. You see, I got a 0.26. We used it in your cell phone. Good teamwork, man. Thanks, appreciate that. That was a pretty good one. All right, so, oh, wait, what's this? We just did volume and we're reading in grams. Alaris people, what do you need to read in? Grams, right? So great question, man. Thanks, Scott. So you didn't want to do it in grams. You actually wanted to read it in milliliters because you're Baxter. There you go. In milliliters. Does everybody understand how a milliliter was defined? 1 milliliter is 1.00 grams of pure water at room temperature, 20 degrees Celsius. It's physics. It's not a calculation. That's pure physics. That's how the empirical scale was formed. It's how 1 milliliter is 1.00 grams. Great question, man. But you like to touch with 0.9% saline. 0.99876 grams per milliliter. Just in case you're curious, so everybody who's reading the service manual to a T says, well, yes, but it says I can use 0.9% saline. That's your specific gravity of it. If you think that nomenclature is going to be any different, trust me, it's not, because what are we all doing? Everybody who wants to admit, you don't have to put your hand in the air. In our shops, we like to use graduated cylinders. Why? Because they're cheap. And we like to use plastic ones because we're technicians, and what happens to the glass ones? We break them. So we have a plastic graduated cylinder, and after we use it for 3 or 4 years, what happens to the plastic? It yellows out. And if you look across it, can you actually see the bottom of the parabolic embolism, right? Not only that, but when you read our service manuals, if you're not using your 5-point scale with a 0 level, which which by the way, have you guys ever tried to move one of those scales around a hospital? It takes a lot of effort to move that scale around because you got to go find another level surface and you got to zero it out and level it. But if you're using a graduated cylinder, a lot of the manuals will call for one that's 0.2 milliliters resolution. And if we're flowing our Laris pumps, what do we got to flow? 20 milliliters, right? If you're flowing a Baxter pump, what do you have to flow? 20 milliliters. So now you have to find a 20 milliliter graduated cylinder with 0.2 milliliter resolution. By the way, if you haven't tried to doing this, it's a lot harder to do than you would think. You can find them in glass, but I couldn't find a plastic one, which is why I don't have one here. Couldn't find one. So what's everybody do? Now, I dare you. Is your graduated cylinder actually a 0.2 or is it a 0.5? Because I go through about 5 Biomed shops a week. I can count on this hand with no fingers up how many I've seen it actually 0.2. I've never seen one. They're always 0.5s. And the argument with the 0.5 is, well, yeah, but the tolerance of the IV pump is such great. It's 10% or 15% that this 0.25 isn't going to matter, or 0.3 difference isn't going to really matter. Well, that might be true, but if you're at the upper end, then all of a sudden, then that 0.2 to 0.5, which is a difference of a 2.5, is a drastic difference. Especially when you consider certain drugs that we're pushing with our IV pumps, because everybody says all IV pumps are just going to be pushing standard IV fluid. So this is a really neat experiment. Go up to your floors and actually ask the nursing staff what they're pushing with their IV pumps, because they may be pushing things like norepinephrine, which it's a very potent drug and can kill somebody, and you're only pushing maybe 5 milliliters over an hour. So very, very slow titrations, which all of our IV pumps can handle. But then all of a sudden, that tolerance is enough to really put a patient in danger. So just some things to consider as we talk about that. So it's really hard to accumulate these things. So that's one of the great benefits about the IDA-6. 0.26 milliliters or microliters, pretty cool. 1 microliter the whole way through. So this is really nice because here I have my amount of time that it took me to inject it. I have my volume and I have my mean flow. You notice I didn't think about this. Way up here I have 2 different lines. One is my instantaneous flow and one is my average flow. So I'll hook up an IV pump here in a second, and you'll see as this goes out, your average flow will start to flatline and your instantaneous flow is going to continue to have waves and peaks and valleys. So not only can you do flow and volume from this screen, but if you're doing the Laris manual by the book, so you're following the little computer screen and you're tippity-tapping your stuff into it, not only do we exceed the resolution and the accuracy of what they're calling for in the manual, and we can read in grams, but then when you're setting up, you're gonna do occlusion first, so I don't have to change my test setup. I don't have to put a pressure meter. I don't have to do any of those things. Only thing I have to do is go occlusion. And here I am. And what's cool about this occlusion screen, I'd ask you about your pressure meters that you have in your shop right now. Does your pressure meter have a peak hold? I heard a yes. Congratulations, sir. Thank you. Very few actually do. I'll speak to our own product. Our DPM does not have a peak hold on our DPM2 or a DPM2 Plus. So what has to happen? You have to be diligent enough to sit there and stare at that pressure meter, because as soon as your IV pump hits the occlusion pressure, what's it do? It backs it off. I'm going to ask you guys a question. Have you ever been able to complete a PM from tip to tail without an interruption? 20 years as a field tech, I never had it happen. Our phones ring, we get an email, you get distracted, you're trying to do all these IV pumps, 10,000 in a month. Can you capture that peak pressure? So what's really cool about the IDA-6 is not only are we going to capture the peak pressure, but the time to peak, if we want to, the time to the alarm, so we can actually hear a microphone and catch when that alarm was. And this is really neat. Residual volume. So say that this line is occluded because somebody got it stuck in the arm rail of a bed or ran it over. That never happens. Do we want to discuss how beds are unplugged? Never mind. There's going to be a nurse in this room and I'm going to get beat before I can get out that door. So if you have this included and the pressure is released, wouldn't it be nice to know how much volume is built up in that line? So we can also measure that residual volume that's coming out. You didn't have to move stopcocks, you didn't have to move ball valves, you didn't have to slide up tubing, you didn't have to do any of that. Only thing you had to do to flip from exclusion to volume was tap a screen. So you can hook up your Alaris pump, go the whole way through all those PM steps. By the way, if you're doing Alaris, if you have the old version of the software, you're running 2 different test sets, right? You're running one for flow and one for pressure. Does anybody even use the calibrated pressure, or calibrated flow cassettes anymore? Because they were really hard to find when COVID happened. So people were just grabbing general test sets off the floor. Managers, go look at your shop and see what they're doing, because you'll probably find out they're not using the calibrated test sets because they're really expensive and you're only supposed to use them for 20 pumps, and then you throw them away and get another test set. just saying. Anywho, so if you're running these through, you get through all your checks, you do your pressure check, you're good. So you have to flow 0.4 milliliters. You push the play button. Here, let's push 4 milliliters. Oh, by the way, check this out. You're very jumpy, Lynn. Okay, air bubbles. We'll talk about air bubbles here in a second, but let me just take this air bubble here, and we're gonna put it against here. Are we still in the camera? Okay, so let's cause a peak pressure. After it stabilizes, and there it goes down. So nice and easy. And there's your peak pressure, 3.29 PSI. Oh, good question, man. You don't like it. Who said they wanted it in kilopascals? Somebody said kilopascals. I heard kilopascals. Again, not an issue. We're gonna discard that test. Let's go back in here to our settings. And you're gonna notice we can measure in millimeters of mercury, kilopascals, PSI, or bar. Our flows and our pressure, milliliters or grams. So you can do volumetric or gravimetric. Okay, back to our pressure. Oh, it was really only 1 cup of coffee, I promise you. Into our measurement screen. So we do our 0.4 milliliters, we hit play, we capture our peak pressure. We hit stop, we go back to our flow and volume. You're gonna flow your 0.4 milliliters for your priming cycle, and then you're gonna go ahead and start your pressure or your flow test. But what didn't we account for? You're not gonna get wet, I promise you. Every biomed shop, if you look at your test setup, you have what, a 1 liter bag hung from the ceiling? It's always from the ceiling or a shelf, never an IV pole, right? And what's across the top of your bag? A big slit. Or somebody got smart and they ran downstairs and stole a feeding bag with the top that pops open and closed, right? It's red food dye. I couldn't put in blood in, they wouldn't let me. But the difference is you notice that my water's not coming out of my bag. This is a really neat phenomenon. This is what we call IntelliPump technology. So what's happening as this is drawing the fluid through the IV pump and into my analyzer, it uses a piston-driven stepper motor. So I have a ceramic piston with a ceramic sleeve in it, and it's pushing that ceramic back and trying to get equilibrium pressure for 0, and it pushes that fluid right back into my bag. I can literally test, how many IV pumps you got in your hospital? 1,000, 2,000, 5,000, 10,000. I have places in Philadelphia with 10,500 IV pumps. That's all they do. You can test all 10,000 of those on this 250 milliliters. As the fluid's coming up, it's recycling it back into the bag, which is a really cool trick. But what's even more impressive about that is we have static head pressure. When you read your service manual, Baxter guys, what's your head pressure? 24.5 inches. So you're supposed to have 24.5 inches plus or minus 5 inches from here to the head of the IV pump and your pressure meter. As your day goes testing and you're drawing this down, you're supposed to either raise your bag or refill your bag. This never changes after you prime it once. And after you prime it, you don't have to prime the system again. So every time you change to your next pump, you're running that priming cycle just because Alaris says you have to do it. It doesn't have any impact on the system. Pretty cool. So just in case you're curious, it's about a 30% reduction in time per Alaris pump because we reduced it in the changes setups. Ta-da! I really was never a dancer. It's really bad. Yeah, sure it does. Okay, so IntelliPump technology. Oh, great question, man. So you're afraid of that pressure differential, and so like what would happen like if I needed a free flow and I wanted to see a free flow, like this pump has to have some sort of a back pressure causing an issue. That's a great question. So let's just go here to our flow and volume channel 4, because that's where I'm plugged in. Hey, key thing about when you're running analyzers, wherever you have an inlet, make sure you have an outlet or you have a very wet bench, and a calibrated towel has to come into play. I'm gonna go ahead and hit run here, and I'm gonna open up this line. And you're going to know that my bag is free flowing, and I've established a flow rate and a volume. What the analyzer is doing is it wants to keep itself at atmospheric pressure at 0. So as it senses pressure on that stepper motor, it's trying to back it off. So hold a perfect 0 for you. So with this analyzer and it pumping fluid back up the hill, we still maintain a 0 pressure. 0.31 PSI. If I shut the line off, where did that little clamp go? There we go. Give it a second here and it'll stabilize out. Ta-da. It'll zero the pressure back out for us. Nice fuzzy screen. So there's some really cool advantages with this. Come on, fuzzy screen. Thank you. Stop it. All right. So if that wasn't cool enough, just acting as an analyzer, I mentioned about air bubbles real quick. So if anybody is using another analyzer on the market, be it our prior model, I'll pick on ours, I'll pick on the IDA-5. Anybody have an IDA-5 or an IDA-4? You do? You got a 4? Yes. In fact, let me know when you're ready to do that and I'll get you a trade-in discount for your new IDA-6. So what will happen with the IDA-5, any of these other analyzers, any analyzer you run on the market, you're supposed to run a cleaning solution through it, right? Something like Micro 90. The problem is if you don't get Micro 90 mixed exactly correct or it sits too long, what happens? You get air bubbles. And the technology of these other analyzers, what typically works is you're going to have a glass pipette in it with a series of photo eyes. So if you have an air bubble come through, will it raise the water level in that glass pipette? No, because it's an air bubble. It's just going to filter off to the top and your volume won't change. So you always had to watch air bubbles. That was a big deal. With the IDA-6, because it's got the piston-driven stepper motor, still in the air. Cancel, channel 1. Flow. Why are you being difficult for me? Oh, I know why. Because I haven't been. Great question here. I need to fix something here real quick. I was in the mountains yesterday. I remember I told you how I was trying to get to equilibrium pressure. We are no longer at the same sea level. We're closer to sea level than where I was at yesterday doing a demo. So every now and again, what we need to do is we need to go back to the screen here and settings and 0 adjust pressure. And take 2 seconds and I 0 at this one too. Ta-da. Ta-da. So if you're in your hospital and you do have to move between like a negative care room and a positive pressure room, you might have to zero out your pressure transducer. Or if you guys are in the mountains, like I was yesterday, and you come down to sea level, you need to adjust these, zero out the pressure meters every now and again. Not a big deal. So we'll go back in and we're gonna hit flow. And even with pure air, we can sense a flow. So the issue with the air bubbles is now gone as well. You don't need to run cleaning solution through it because there's no glass pipettes or eyes, photo eyes to try to keep from occluding. The recommended fluid is pure distilled water. If you don't have a distiller in your hospital, go down to the grocery store and pick up a gallon. It's like $1 for a gallon. And as you see, you can test for an entire week on month, year on a gallon of distilled water. You don't have to put red food dye in, but it looks kind of cool. So, okay. Discard that. The last but not least over here, let's talk about this bolus and PCA. So with this, has anybody ever tried to measure a PCA pump and catch what the bolus is? So this is kind of cool. Any places you see this asterisk, I can program in my baseline titration. So maybe it's 1, 2, 3 milliliters an hour. And every time I push the button and get my bolus, you get like a little square waveform. It'll measure the bolus duration, the bolus volume, and the bolus flow for you and calculate it out. Because then you really want to run 3 or 4 or 5, 6 of these things. So every time you push it, it's going to average those together and give you the average bolus. Here's a neat little thing about IV pumps. Do IV pumps actually measure the output? Does a syringe pump measure the output? No, it does not. No, it does not. Let's talk about a syringe pump for a second. How do we calibrate most of our syringe pumps? We got a strain gauge. We're going to put a strain gauge into it, right? We're going to make sure that that linear actuator is spinning at a known rate and at a certain pressure. And then we're going to put in a bunch of cylinders to determine what size syringe we put in. Has anybody ever taken 10 seconds and actually made sure it's outputting its volume? With your IDA-5 or IDA-4, have you ever tried to do a 5 milliliter an hour rate? It took like 20 hours for the thing to stabilize. No one ever did it because it was a pain. We can actually get that same rate, 2 milliliters an hour, in 6 minutes. We can get a stable rate for you. Is that cool? All right. So all those things look pretty cool, but let's get into the meat and potatoes now. Let's discard this test. And let's do something fun. Because we talked about automating things. So everybody who's a Alaris, I'm sorry. Right now, because you're Alaris, you still have to run the Alaris software. There's just no ways around that. But if you're not a Alaris and you're a Baxter, BD, or any of these other ones, we can start to have a little bit of fun with this. Because I can take 3 simple instructions and have anybody servicing an IV pump instantaneously. 3. Step 1 is turn on your IDA-6. Step 2 is turn on your barcode scanner. Step 3 is push this blue button. And it'll automatically populate my IV pump. I can select my IV pump. And we might see that you might have multiple versions of the procedure. Why would you want multiple versions of the procedure? Well, if you had a new person come in, you might want them to have one that has all the pictures of how to hook it up. But if you're a senior level technician, you've done 10,000 pumps, you might not want to look at all those pictures. You just want to streamline it through. Or more importantly, if I had a wager, when you did an incoming inspection, you followed the manual to a T. After you did the incoming inspections, you never followed that manual to a T anymore, did you? We all follow alternative maintenance programs. So this gives us the ability to put in multiple different procedures depending on our needs. We might have one that's 100% by the book, and we can have another one that's an alternative maintenance. Maybe we want to have a checkout and repair procedure. Maybe we want to have, and you can build multiple procedures for it. So we're just going to go in and we're going to select one in here. Baxter. And you'll notice it has all the pertinent information you need. The asset ID, we could add the serial number to it, your worker ID. You can add your tester, and we can go ahead and push run. And we're going to need to do a pump inspection. And continue. Enter the serial number. So we can just simply go into here and enter our serial number. I'm making one up. You guys want some numbers here? There we go. We can enter the serial number in it if we needed to, or we can get rid of that step, whatever you want to do. Continue. Software version 6.5. 6. Is that a 0.5? Okay. And this is where this gets fun. It's active lug driver in there. And you can simply just go through, read the instructions right on here, do what it's asking, and move to the next step. I even have procedures in here where I've added pictures so you know how to set up this entire test rig. You can put JPEGs in it. If you really wanted to, and you have brand new technicians, because all the new techs always get stuck doing IV pumps, right? Because nobody else likes to do them. You can even add a video in it. So if you want to put a video of how to set all this up, you can put a video in there. They can simply follow the video. We're going to continue to advance through all these steps. Pass. Keypad test, which by the way, if you ever do this keypad test, it takes forever. Keypad test. And you notice every time you pass a step, what happened? We've got a green light advancing it. Where's all my managers at and directors? Managers and directors. So say we happen to have this happen and we fail a step. This is where you get to play a choose your own adventure. Remember this choose your own adventure books from back in the 90s? So when it failed that step, you can choose one of two things. When we set up this test, you can say, hey, listen, that step failed. I want you to go fix that step before you finish testing. Or you might say, okay, that failed. I want you to complete the work order and see if anything else fails, and then fail the entire work order and come back and make a repair work order. So you can choose which way this adventure goes. And we're going to continue to do these pass and fails here for a second until we get down to the flow test.
Justin, if you didn't want to do all that kind of button pushing and the visual inspection, is there a way to kind of automate some of that?
There sure is. So we can take and build these tests so that you might have, see how all these are labeled 2.4 AC power adapter? So this literally went the whole way through the manual. So say I don't want to have all these steps. I want to assume that if I did section 2, all the steps inside of it passed. No problem. Let's just abort this one. Continue. I have very dry skin today. We could actually run another procedure that would just have the very basic steps. Like this one. So now instead of having to type everything in, you choose your software version. Does this manual look familiar to anybody who's a Baxter hospital? And we'll knock this down to 3 or 4 simple steps. So you can expand them as much as you want. You can have 10,000 steps. You can have 10 steps. And we'll pass them all through because where I want to get down to is where we're actually going to hook it up. Network status, upstream, we're going to pass that one, and let's get down to downstream. Air detection test, downstream. So now you have everything that you need to do to set it up. It's going to take longer to set this IV pump up while we do this. But the next step that's going to happen here is all of our tolerances are already built into it, because nobody's ever pencil whipped a PM before, right? If it says the limit's 5.0 and it's 5.01, we've never said, yeah, it passes because it's 3M and you're stuck in 8. Yeah. So there's a few different ways I've done that. So one of the ones is this is actual Baxter's real test set. So what I did in their test is when I did that upstream occlusion test, you have to clamp off upstream, and then as soon as you clamp up upstream, you disconnect, you let it run for 3 seconds, it pulls an air bubble, you reconnect, and it sucks that air bubble in. Once it sucks the air bubble in and it throws the air detection alarm, I simply open the door, and you saw how it free floated right back through the pump. %. Yep, it free floated right out. Yep. Anybody else got any questions? What I have to type all these numbers into this thing. It takes forever. Yeah.
I see that when you're putting in the information, you can add in, but you have to put in the serial number and things of that nature. If you wanted to have a complete record, could you also add in like what the IP, what's the MAC address?
100%.
And this record goes into your CMMS, right? So it completes your actual data record.
Yes.
Okay, so that would work out really trying to show up your
100%. So we have what's called an open API. I'm going to go ahead and start this occlusion test. Oh, hold on. No, I'm not, because I didn't hook the line up to it. Now my line's hooked up. There we go. And I can start getting my pressure to run up. So I can talk to you while this is doing it, because it's going to take care of it for me. So we have what's called an open API. What is your CMMS system, ma'am? Nuvolo, we have a working API with that. So what your technicians would do is they would go into Nuvolo, open up their work order, they get into the procedure, and there'd be a button that says OneQA. You click that button, it opens up the OneQA, drives the analyzer, captures your information, and drops it right back into your work order for you. So there's two different things that you could do with this. Some people just want a PDF. PDFs are great, but here's my perspective. This is my perspective only. The problem with PDFs is the only thing that you did is you said is I completed my job. That's it. It's like pass-fail testing. Who does pass-fail testing versus actual results? You don't have to put your hand in the air. Pass-fail testing, there's some great advantages to it. You have a nice cushion for legal action because it said you passed that day. But that's the only thing that you did. The only thing that you did with that pass-fail testing is said that I completed it. If you do statistical analysis, so when you actually start to capture this, you can start to do trending over time. So Nuvolo has capabilities of, if I took this actual peak pressure, by the way, I'm not staring at this and my pressure hasn't back down, 13.28 PSI, I could now run all 5,000 of my IV pumps. And if I put those exact figures into it, I can go into Nuvolo and use some figuring, and I can grab all those data points and I can say, what was my average peak pressure this year? And in 5 years, equipment doesn't fail like this. Like you don't see a drastic spike. What you'll see is like a hockey stick curve. So you'll see static pressure outputs for a long period of time, and all of a sudden you'll see, because you buy your entire fleet at one time usually, and they'll start to fail. So if you can start to take this analysis, take this information and run it over 5, 6, 7, average life expectancy of a medical device, 7 years, right? So if you can run this over 7 years, and you can start to do some analysis and saying, hey, what's my percent deviation after 5 years? And once you start to see a deviation, you can now move your policy, your program from responsive maintenance to predictive maintenance. Hey, admin, just so you know, we've had these pumps 7 years. We've been averaging a 3% deviation. This year we saw a 7.5% deviation. There's a few things that could have happened. COVID happened. My entire staff is all now temporary nurses and nobody knows what they're doing. They're not trained on these IV pumps. That hasn't happened to anybody, did it? Or the other side of it is, it's been 7.5 years. We had this deviation. We went through. We couldn't find any training issues. We're starting to think these pumps are about time to get replaced. But what's great about this is, did you see me write down any results? Did I put anything in a notebook? Did I type it into a computer? It did it for me automatically. So I didn't take up my technician's time doing this. And way up there's my green light, knowing that my step passed. Because here, where my tolerance is automatically inputted into the work order for me. Because I built this program, I had my exact tolerances already put in, 13 PSI with a high of 19 and a low of 7. I programmed this once. So if you have a multi-hospitals network, you're in charge of one, it doesn't matter. If you have one hospital, 10 hospitals, 5,000 hospitals, the beautiful thing about OneQA and the software that this is running is I can build this procedure one time, I can standardize it one time. I save it one time. The very next time any of my technicians get into it, they have the most updated procedure. I didn't have to say, hey, Dave, can you go download that procedure and print it off? Do you have it in your binder? That's all gone. So there's 3 levels of operators to OneQA. There's a user, there is a author, and there's an administrator. So Scott, you'd probably be the administrator since you're the big boss. You're gonna unlock it, you're gonna say, hey, Dave, I need you to go modify this procedure because we need to do revision control every now and again. So it's revision control month. Dave goes in, makes the corrections, says, hey, Scott, I got it corrected. You're gonna wanna double check, right? He looks and goes, yeah, that looks good. Enter. The second Scott authorizes it with his password, every technician in your network has that procedure. You build it once, 500 techs, have it instantaneously. You could have people in Taiwan. The second you hit enter, they have it. I'm gonna start the next test and we're gonna go on with that a little bit more. Continue. Flow and volume. 40 milliliters. Stop this. Clear program. Any other questions while I'm typing buttons? Come on. Please. Sure. Oh, that is a good question. Nope. Hold on one second here. Let me hit play here and run here. There we go. We got an instantaneous pickup and everything's running. The way OneQA works is OneQA is a cloud-based service. It's a secure cloud-based service. So if you get our service, I can't go in and say how many, I can't see your procedures, I can't see your work orders, I can't see your data. I can tell you how many users you have in on the system at once. Anybody ever sit through any data security classes recently? None, right? Nobody. We've not talked about data security at all. Every conversation. If your CMMS goes down, where are your records? If your data gets hijacked, where are your records? The beautiful thing about OneQA is any procedure that you run through our system is backed up on the secondary as part of the system. So if whatever your CMMS is goes down, you can always get right back into OneQA and find your procedure and find your work orders and your entire history that you ran with that system. Another great question, man. It's based on how many users are on the system at once. So say you have 300 technicians in your hospital, big hospital, 300 technicians, right? You're massive, man. But they're working 3 different shifts, so the maximum you only have is 100 guys or 100 technicians in a time. You'd only need 100 seats. And then if you call me up and say, yo, listen, we have people who keep getting kicked off, I need 5 more seats. I say, clickety click, and you got 5 more seats. Or you say, hey man, listen, we've been running this for a year. Can you do analysis and tell me what the max number of people we've had on at a time? We jump into the system, can't see your data, but I can say, hey, you had max, you had is 72. Oh man, can you adjust my contract down? Easy enough. Pretty cool? Yes, ma'am.
Is there a big difference between your IDA system and ES601 Plus, which also has a large amount of automation and it tests electrical safety and it does all of that with the device and passports to one graphics?
Our ESA 601? Our ESA? I'm very sorry. Big honking thing?
That's all. 170 records. You hit the button and it automates on your test.
6.1, we have a 612, 15, 14. Oh, yeah, I can't speak to their software. I'm sorry. Ours works with all of our platforms. If you come down by the booth, the same software that I'm driving this with right now, and by the way, this is running free. This is our first in our new ecosystem. And as you see more of our analyzers come out, you'll see it all with OneQA on board. But we can also, with the same software, automate our defib analyzer, our gas flow analyzer, our electrical safety analyzers, our ProSim8 patient simulator, which is really cool because now you can build scripts in it instead of pushing all the buttons. You push one button and it advances it, so like you can go down to the nurse's state, you go admit a patient and run an entire code and see how the hospital responds. There's a lot of really cool things you can do with that. So yeah, we can drive all of our analyzers, put all the pictures into it, run all that data and bring it all right back in for you. So your technicians are now being able to focus on their equipment and focus on patient care. You're welcome. Come on down, like we'd love to show it to you. It's really cool when you see the whole thing working together. So what's really neat about this screen is I'm gonna zoom in here for 1/2 a second. I want to pull this up. If you watch this, you're gonna notice something. This is my instantaneous flow. This is my instantaneous flow across the bottom, and you see what happened here. and what happened here? What happened here and what happened here? Something's wrong with this IV pump. What's interesting is my flow has maintained, my mean flow is 38.7. So my mean flow is still within tolerance, but there's something happening here. So if I wanted to, I could click on my screen and see, I have got to put lotion on my fingers, at the exact point in time, what my peak flow was and what my time was. I actually know the issue. This is an older IV pump. I have a bad finger in it. It needs to have some silicone put in it. But my point is, you can actually hear it grinding. You can now look at your outputs and see exactly where, if you have any peaks or valleys. So do I have any clinical engineers in here who are not biomeds, but actual clinical engineers? There are some really neat things that you can do with this when you're going into a clinical application. Because when you start talking about administering these drugs to a patient, what is the spacing that you have around your ICU beds? Do you have 14 foot on all sides? Nobody does. So if you have to cram 8 IV pumps in there, can you actually do it? How long are your PICC lines? Are you able to push through a 16 gauge needle? So if you have to extend your PICC line, so you have the distance for your IV pump, and you have to run it through a 10 gauge, or I'm sorry, an 18 gauge PICC line, what's the head pressure and what's that doing to the volume infusion with your patient? Things I didn't talk about, but you'll also notice on the screen, if I needed to, I could introduce back pressure. So great question. So I told you we should only push distilled water. But if we wanted to do a simulate, like we're pushing a bit more viscous solution, blood, or other things, feeding different drugs, we can take the differential and enter it as a back pressure and put a back pressure against the pump pushing it in. I'm running out of time because I get so carried away with this. So let me show you this stuff, and this is why this gets even cooler. More cooler? More cooler? Is that right, Lizzie? More cool? More cool? I'm a hillbilly. I speak redneck as my primary language. Hillbilly is my second. Yeah, we're good, man. We're good. Okay. So I'm going to flip this over. Say it's calibration month, and you have 10,000 IV pumps. Do you want to lose your analyzer instead of send it in for calibration? No. So, oh, John, you got me. So the only thing you have to do is you just have to take out this screw here and this screw here, and what will happen is this channel will pop right out. It has a little micro USB. You mail this in. This is what gets serviced. And then when you get it back, you simply slide it back in. So great question. What a lot of people are doing is they're buying multiple analyzers. They're getting 2 or 3 a 2 channel and 1 4 channel, so they have 2 extra channels. They send 2 channels in. When they get it back, they put those 2 channels in the next analyzer and take those 2 channels out. David, 100%. When we stick it back in, the system recognizes the serial number and logs that serial number onto your work order. So anybody in ISO certified hospital, it will automatically log the serial number of the base unit as well as the channel onto each and every one of your work orders. So if you ever have to go back, you can trace each and every IV pump you serviced with that channel. The calibration's housed on this. They're really durable. I'm not going to throw it at you. I thought about it. I'm not worried about that breaking. I'm worried about him breaking me, man. That's a long distance to that door, and I'm fat and old. All right. But nobody asked the big question is, how are we transmitting back to our network? Not with Bluetooth. Why? Why don't we want Bluetooth in a biomed shop? Bluetooth is a class 1 non-secured, unauthorized for medical equipment device. It's great for barcode scanners and wireless headsets. I'm here to tell you, I love to talk. If you guys want to ever give me a shout, we'll have a great conversation. But if I'm partially deaf, so I wear a wireless headset. If I'm talking to you on my wireless headset and my wife drives into my garage with my Subaru, you will be talking to my wife because it will steal the Bluetooth signal every time. John talks to my wife a lot because it steals my Bluetooth signal every time. So we do not want to use Bluetooth to transmit back and forth. So what you'll notice on the back of this IDA-6, is it on the screen good enough? Yeah, this kills me. Who's over the age of 35? Do we remember what Bluetooth or what Wi-Fi adapters looked like 20 years ago? That's a Wi-Fi adapter. Really? Secure Wi-Fi. So yes, you can put all your data security in this, and you can go over your hospital's Wi-Fi network and launch your results right back to your CMMS. But great question, because not all your sites have Wi-Fi. You might have to go down to the lab or something. So the IDA-6 is capable of storing 10,000 results internally. And then when I get back to my shop, if I don't want to use my Wi-Fi, I can simply tag into my USB-C. So then why do I need to have 3 USB ports? Well, because I can use the Wi-Fi, and I will allow my Bluetooth for my really cool barcode scanner, which also does, you can use any barcode scanner. These are the ones we sell because they turn off and on with a simple push of a button. You don't have to sit there and relink them every time, and it'll read QR codes. So these ones are really cool. The other thing I can do is I can export straight to a printer. So if, for instance, I have a shop, somebody's bringing in something I need to check out real quick, I can actually print my results with the OneQA system right back to a printer. Whew. Lizzie, what'd I miss? So that's something I'll cover here real quick. There's a lot of thought and engineering that went into this. And one of the concerns that people have is because we're dealing with fluids, there's a possibility of getting fluids into the vents in the back of it. But I want to point out, if you actually spill fluid on this, if you look at the plane of the device, you can't get to the open ports. So they actually did that, and you can darn near barrel this thing down the hallway and pick it back up. It's fine. They have to do is test with the ball bearing, and it knocked it across the floor. It's unbelievably durable. So what happened is, when we built this thing, we assumed it was going to be a benchtop unit because every IV pump tester is benchtop. Everybody's benchtop. Right next to the sink and the calibrated towels. But what happened is we quickly figured out, because we can do some telepump technology with static head pressure, now I can grab a crash cart with an IV pole on it and set this up. And I can take a little UPS and plug it in, and now I am portable. So when people talk about true time savings, you're right, man, the 30-minute test is a 30-minute test. If Baxter says 30 minutes, you're running for 30 minutes. I can't make that 30 minutes any less. But what I can save is the number of steps we have to go between the patient floor and back. We now have the ability to take this on the patient floor and go find that last 10% of IV pumps that are always in the women's locker room above the ceiling tiles. Trust me, we did a study years ago at a Pittsburgh hospital, and we're months in a bunch, back when RFID first came out and we could ping them and make them chirp. We're walking down the hallway like, where is that sound? The nurse's locker room. They had them in the ceiling tiles because they needed one. So there's a really great study. Yeah, because if they needed one, they didn't have time to wait for central sterile to come up. They knew these ones are good, so they held on to them and stuck them in the ceiling tiles. Can't knock them. It's great. If you haven't had time, please go out and meet your clinical staff because they have a lot of challenges we don't always understand as biomeds. We just did a webinar on fusion pumps here a few weeks ago, and that communication breakdown between nurses and biomeds has been, it's just bad. They have a lot of challenges and they're afraid to bring them up because everybody says, hey, listen, I brought this thing back down to my shop and it worked fine. But as this young lady, as the clinical engineer, can attest to, it's great in a clinical setting, but once you go out and put all the variables in, the PIC lines and the head spacing and the blah, 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 all of a sudden these issues arise. So just little plug, love your nurses. I have 4 minutes left. John, Lizzie, anybody, did I miss anything cool in this thing? So I'll start writing quotes and POs as you guys are leaving. No, sincerely, if there's any questions, if you'd like to try it out, please get a hold of your Fluke rep, give us a call, swing down by booth. We're 101, so if you go through the door, hang the left, the very end, we're down there. We have it set up. You're welcome to come down and try it out. There's a bunch of videos online, FlukeBiomedical.com and our YouTube channel. We have the Alaris pumps, we have Baxter pumps. You can see it all. Sir. Yeah. Yes. Lynn. Cool. The automation is really cool. Like we've had it out for about 2.5 years now. And as we get more and more CMMSs to interlink with, it's getting more and more powerful. This is our first device. I don't have to be linked to a PC to run. This is completely independent. I can take this and I can go test all darn day long and come back and sync it back in. I'm only running one channel now. Great question, Scott. You didn't ask if I can see all the channels at once. I simply just go here and I can view all my channels at one time. I can simply select which channel I want to do, and I can flip-flop back between them. But the biggest thing is when I'm doing this, I am now able to focus on all the other parameters of my job. I can be getting the next IV pump ready. I can be filling up my Biomed sticker because nobody ever forgets to put those on. Let's make this small. I can also do trumpet and bell curves for all you super geeks who want to do a trumpet curve. It'll calculate it for you. But everything's here. My tolerances, my outputs, everything. When this is done, I can actually even sign the screen with my finger. I can go back and fix any of the steps that are wrong, but as soon as I hit done and complete, it saves it and it's no longer editable. Editable. We can't change it. And it syncs right back to the system, so you now have an electronic signature on your each and every test. Dramatic pause. Spirit fingers, thank you for joining us. One-on-one, booth 101, come hang out, please. Yeah, man. No, but you know, if you had an RFID scanner, I don't know why it couldn't be. It's 100% plausible, dude. Yeah.